Now, yet another entirely useful feature is the ability to automatically BCC certain recipients. We're going to begin similarly to the way we began the canonical maps section. We'll show you how to do it on a global scope where all messages get BCC'd to a given user. Let's pick the root user as an initial or a starting point. We'll modify the main.cf file, and we want to specify the always, which may or may not be in the file already, depending on your setup, the always_BCC directive. As you can see, it's not defined, so towards the end of the file, we'll just insert a comment which says, added by Dino on today's date, and we'll then define this particular directive. Again, directives can be defined at any time within the postfix environment. There isn't really a special order that needs to be followed because postfix will compile everything before allowing the daemons, the master and the various daemons that are reliant upon its directives to process it anyway. So it all gets compiled and checked well before any of the daemons can consult it. Same goes for variables. If you've read the postfix documentation, you know that you can make references to variables that have yet to be defined, which is pretty neat. So with always BCC, for example, you may have a scenario where you need all messages traversing a particular mail server to be BCC'd to an actual user or perhaps eventually on to an actual file. Since you know how aliases work, you could set up an always BCC to send to a recipient who's really not a user, but via the aliases file ends up appending to a file. And since one of the 5 different types of aliases that's supported by postfix as well as sendmail is the ability to send items into a file in append mode, it may be a great way for you to provide or to store and to provide a service such as an audit trail within any environment. So you may have a business need to store all messages traversing a given mail server. Let's begin with the global option. The directive is always, and it's pretty straightforward, BCC equal the name of the user who should always get a copy of every message traversing this system. Let's begin with a logical user, the root level user. So we're pretending that the root level user, the most important user on a Linux box and a Unix box, should get every message or get a copy of every message unbeknownst to the senders and receivers of various messages. So this happens transparently under the hood unbeknownst to the senders and recipients that are communicating through your mail server. But again, the idea is that this mail server is a corporate resource and messages should be logged. Perhaps you're in a banking environment where all correspondences need to be recorded for the sake of protecting the organization, the client, and so on. So always BCC a given user is pretty straightforward. Let's save it. Postfix reload. And of course postfix or postconf pipe to less will reveal all of the directives that postfix is currently processing. So here's the always BCC equals root. So let's begin by sending a message. We'll go to the third shell because we're still logged in as a user Dean here. And let's compose a new message. This message will be sent to Linux CBT SUSE1. So a message from Dean to Linux CBT SUSE1. Testing always BCC global directive. Let's include a body. This is a test to see if postfix really BCCs the intended recipient. Now, of course, as a non-privileged user named Dean, we wouldn't know if this message was actually sent. So we have a new message. Now, this new message that you see here has been returned by the vacation program because we still have it in place for the user Linux CBT SUSE1. So obviously, between the time that we've shown you how to use a vacation program and now, the user Linux CBT SUSE1 is still on vacation. Nonetheless, the message has been sent. Now, in the left window, we're logged in still as the user root, again indicated by the hash mark. Also notice it says we have new mail. So let's take a look at what's happening. We'll launch our mail user agent in the left window, and there's a message. New message, testing always BCC global directive. Note that we didn't send this message to the user root. And also the reply, which was generated by the vacation program, was also sent to the user root. Here's the reply. And if you reveal the headers of this message, you'll see that the message was really sent from Linux CBT SUSE 1 to the user Dean, but it got delivered to root because we have an always BCC in there. And here's a message from Dean, and it says to root, but it's really just postfix BCCing the user root. Now the original user, Linux CBT SUSE 1, did get the message. In fact, in a separate window we can confirm it. Let's exit this particular window, and we're logged in now to our local system as Linux CBT SUSE 1. So let's launch MUT. There's the message sent from Dean, testing always BCC global directive. There it is. There's really no indication, even if you reveal the headers, that the message was copied to the root user. So that's how you use always BCC. Now, you could set up always BCC with an alias, as I've mentioned, which ultimately sends all of the messages to a file in append mode. That would simply be done through the aliases file. So currently we have always BCC set to go to the root user. So as a result, it goes to the root user. Let's take a look at the main.cf file again. We'll find always BCC, which is at the end. Again, this is going to root, who actually has a mailbox. This could go to an alias, and postfix would further expand that alias to the destination, which can be one or more of 5 different aliases path, including one-to-one mappings, one-to-many, include lists, redirections to pipes, as well as redirections to files. Great. Now we can be more particular about what we copy on the always BCC. Rather than always BCCing a given user for all messages that traverse the system, let's say we need to be more specific with our BCCing. Then what we can set up is either a sender or a recipient or a recipient BCC map. Let's comment out always BCC equals root and define this new map. So we're getting good practice here with defining maps, from canonical maps to BCC maps. If we'd like to BCC messages from a particular sender, let's say to the user root, define a map, call it sender BCC maps, and again it's going to be equal to type and the actual map. The type is hash, which is the default, and the map is located or will be located in etc postfix, and we'll define a file called sender_BCC. And we can call it whatever we want, but this should suffice. Now this file doesn't yet exist, so we're going to define it now and use postmap to generate a hash database form of that particular file. Now if you're following along and you find that postmap doesn't work for one reason or another, ensure that you have the Berkeley database libraries installed, both the development package as well as the main Berkeley package. And the later the version, the better. If not, go to SleepyCat's website and download the latest version, because postmap relies upon the existence of the Berkeley libraries on your system for using the hashing algorithm for generating the hash databases. So back to sender_BCC maps. I think you know where this is going to lead. It's going to match on the sender address. If a sender matches, it'll BCC it to the target. Again, the map is a two-dimensional, two-columnar file which has a left-hand side and a right-hand side. The left-hand side specifies who the sender is. The right-hand side specifies who the BCC recipient is. Let's save this particular file. We're not ready to reload postfix yet because we need to define the map. So let's nano sender_BCC. And on the left-hand side, again, you can specify comments. It's really just left-hand side. Left-hand side will contain, as I've mentioned, sender to match. And the right-hand side will contain BCC recipient. This is really as simple as it gets. So on the left-hand side, we'll say any messages from Dean, send it to a given recipient. So from Dean, send it to root. This is all we need to do. If you see a message from Dean, send it to the user root. 2 columns, can't get any simpler. Again, if we cat canonical, which we're currently not using, we have a similar syntax. Dean changes to Dean.Davis, but currently we're not using canonical maps, and in fact postconf will tell us. We'll take a look and try to find the canonical maps. You'll see it's undefined. Same for the recipient as well as sender canonical maps. Now that we have the file, before we restart postfix, we should run postmap against this particular file called sender_bcc. Echo the exit status, it came back cleanly, and if we lsltr, we now have a sender_bcc.db. In fact, file sender_bcc.db will echo that the file is a Berkeley DB file. Super. Now we can restart postfix. So let's execute postfix, reload, and we'll echo the exit status to see how postfix returned. We'll also execute psax grep for master, and it's up and running. So now all that's left to do is for us to fulfill what we have in sender_bcc. If Dean sends a message, root will get a copy. Let's go into Mutt. It's currently blank. Now on the right hand side we're logged in as the user Dean. So let's compose a new message, and we'll send this message to a totally different user. We'll send it to LinuxCBT Suzy1. Testing sender BCC map. No body, and we'll just send the message off. Now that message has been sent and it's gone. Now notice the vacation program didn't respond. And what we did mention is that the vacation program is tuned to respond once every interval. The interval is defined. Just do a man vacation, you'll see what the default interval is. And that's to mitigate denial of service attacks as a vector. The vacation program as a vector to denial of service against your MTA. So we've just sent the message to LinuxCBT Suzy1, and the window to the left of it will reflect that. There's a new message. Testing sender BCC map. We'll delete them all. And now on the left hand side, when we move the arrow up, there's the message. Testing sender BCC map. Again, postfix has redirected the message to root, although it says in the original envelope information from Dean to LinuxCBT Suzy1. When we open the headers, from Dean to LinuxCBT Suzy1, but the postfix MTA has copied the user root. It's added these headers to say deliver the message to root. So that's how you do a sender BCC, and the same applies to the recipient BCC. You can say, for example, match the recipient. If it does match, send a copy. And these are powerful ways of rewriting or redirecting the flow of traffic. Now from Dean's account, we can also send a message outbound. We have an account set up at the production system. It's called LinuxCBT, or on the production system. The user account is LinuxCBT Suzy1 at linuxcomputer-based-training.com. This will actually leave our local system and head out to the internet. Testing sender BCC with public account. We'll send it, and this message was just sent, and on the left hand side there's the message. We actually sent it. It went out to the internet, destined for linuxcomputer-based-training.com, but we did get a copy of it. Now we can check our logs to see whether or not the message was delivered, but that's a separate issue. And it was delivered, LinuxCBT Suzy1, linuxcomputer-based-training.com, which is on the internet. The relay is mail.linuxcomputer-based-training.com, located on the 12 backbone. Delay 2 seconds, status equals sent. So the message actually made it there, and in fact, in the second window, we'll purge these messages, and let's SSH into mail.linuxcomputer-based-training.com. We'll authenticate, and we'll launch Mutt on the remote system. And there's the new message, testing sender BCC with public account. Again, I went through all of this, mail scanner and so on. The message was sent from Dean at LinuxCBT SuzyServe1 to this particular user. And there's no indication here that root got BCC'd on the message, other than the fact that we put BCC in the subject, which is exposed to everyone. But nonetheless, it's all happening transparently, and that's the idea behind using always BCC as well as sender BCC as well as recipient BCC. So the recipient BCC works in reverse. It'll just analyze the envelope recipient section, and if it performs a match, again, let's cat the sender BCC file. All we have is as follows. If the sender matches Dean, copy root. Same thing for recipient. If the recipient matches user A, copy user B. Pretty straightforward. So address rewriting in postfix is pretty powerful. Some of the things we can do, including automatic BCCs, canonical rewrites, using my origin to strip a portion of the fully qualified hostname, and the list goes on and on. There are many, many things you can do with the rewriting capabilities. And again, some of the rewriting takes place in the actual cleanup engine, the cleanup process, which we'll see above. Some of it takes place here. The more complicated stuff gets done within the trivial rewrite daemon. And once all of that is performed, the message is placed into the incoming queue, at which point the queue manager moves the message into active and decides how to deliver the message. Super. So you understand a little bit about how the rewriting features work with postfix.